parallel resistors. Let's look at the circuits here. We have a voltage source. This is positive, this is negative. The value is Vs1. There are 5 resistors, R1, R2, R3, R4, and R5. And we can see they share the same 2 nodes. So this is one node they share. This is another node they share. So they only share 2 common nodes altogether. So the voltage here, VR1, VR2 up to VR5. So this is positive. They all defined this way here. And this is a negative of the voltage. VR1 equals to VR2 equals to VR5. They all equals to Vs1 because the same sign here of the voltage defined as the same positive sign along this node. So let's look at how we simplify this circuit because we have 5 resistors. We want to see if we can simplify this circuit a little bit. How do we do that? First of all, we apply KCL to the node here. There's only 2 nodes, one here, one here. So let's apply KCL on this node on the top. KCL says that current flow into a node equals current flow out of the node. In this case, the current flow into, that's I. In current flow out to, there are 5 of them, from I1 to I5. Therefore, current flow into, that's I here. In current flow out to, I1 plus I2 up to I5. And then we're going to apply Ohm's law to obtain equations. And then from there, we can obtain the quantities we're interested in, either the voltage or the current. In this case, we applied KCL because everything is in parallel connections. There's no point to apply KVL here because there's only one voltage here. We don't get much information if we apply KVL. Can we apply? Yes, we can apply, but there's nothing new information obtained if we apply the KVL. If we apply KCL, we apply new information because it's related with currents here, and all of this current I1, I2, up to I5, they're all unknowns. We're interested to solve all of those. And the voltage we know is equals to Vs1, right? That's trivial answer. Next step, we just use Ohm's law. And we are going to obtain I1 to I5. By Ohm's law, I1 equals VR1 divided by R1. That's VR1. And I2 equals VR2 divided by R2. I5 equals VR5 divided by R5. We know this. This is very straightforward here. As they're all parallel connected, so VR1 equals VR2, they all equals to VR5, they're all the same voltage, they all equals to Vs1 here. Then we plug in VR1 or VR2, all of this by Vs1, 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 Vs1. Then we move Vs1 out. So this is a relationship for this circuit here. I equals this big quantity here multiplied by Vs1. So in other words, we're going to have Vs1 equals to R1 plus R2 plus R5 minus 1 I. This big quantity here going to move the other side of equation, so that's the inverse here. Okay, you take the power of minus 1, you multiply by this current. This is the relationship of the voltage Vs1 and with the current. And from here, actually, we're ready to obtain the equivalent circuits. So this is the equivalent circuits we're interested in. This is the same terminal here. This is the same voltage source VS1, the same value, the same sign here, the same current I, the same direction. What is VEQ equals to? So VEQ equals to VS1, right? Because they share the same sign. And then Ohm's law, REQ multiplied by I. Compare from here to here, this equation 1. Let's compare equation 1 and equation 2. This equation 2. So we can obtain REQ equals to R1 plus R5 minus 1. Or can have this relationship. I take this, move to this side, and REQ to another side. 1 over REQ equals 2. Basically, you take reciprocal on both sides. As we can think that way too. R1 plus R5. 1 over REQ equals to 1 over R1 plus all of this until 1 over R5. Or if we use conductance, thinking about conductance is 1 over R. So 1 over R does become G, and that's GEQ, and this is G1, G2 up to G5. REQ equals 1 over of GEQ, and GEQ actually equals 1 over REQ. That's conductance, that's resistance. Let's look at a special case that we have only two resistors in parallel, R1 and R2. And this is current I, this is I1, I2, this is voltage source V. What is REQ? REQ equals to 1 over R1 plus 1 over R2, and take the power of minus 1 here. That's reciprocal here, 1 over. And then we do a little reorganization here. That's equals R1 multiplied by R2 divided by R1 plus R2. So we know this. This is a special case. I have a question to ask at this point. Suppose I have another resistor here, R3, then REQ equals to R0, R1, R2, R3, and R1 plus R2 or R3. Does it equals to that or not? So that's the question I think everyone should know. Next, let's look at current division. Here we talk about voltage division. When we talk about voltage division, every elements are in series connection. Here, when we talk about current division, everything is in parallel connection. Let's talk about here the voltage across R1 and R2 the same. We call it Vs, small vs. Vs equals to what? The current multiplied by this resistor here. What is this resistor? R1, R2 are parallel. If we know Vs already, what's the current I1? I1 is equals to Vs divided by R1, and I2 is equals to Vs divided by R2. So we plug it in, we can see here what is I2. I2 equals to R1 divided by R1 plus R2 and multiplied by IS. IS, that's the current here flow into this node. This node is connected to R1 and R2 in parallel. And what is I1? That equals IS R2 divided by R1 and R2.